Hello class, this is section 7.2, multiplying and dividing rational expressions. So when you multiply and dividing rational expression, we have to think about as multiplying or dividing fractions, because rational expression is another way of the fraction, but which includes variable, which is like a letter. All right, so step for the multiplying rational expression. First thing is you need to factor everywhere. So you need to factor numerator and denominator completely. And then the second step, once you have a factors, you can you can do the cancellations. And then you don't have to multiply out. Okay, you just need to leave it as a factor form. Okay, so let's do number one. So in number one, the 9 is only one term, so there's nothing to do about that because it's already factor form. But denominator of 2x minus 8, we can factor as 2 times x minus 4 times. And the x minus 4 is already linear, so just put the parentheses around because that's the factor form. And the 3 is only one term, so there's nothing you can do about it either. So now, time to cancellate. So cancel 9 and 3 possible. So 3 goes 1 and 9, 3. And the x minus 4 cancel with x minus 4 here. Then you're done. So everything has been canceled as a common factor. Now the remaining factors are 3 from the top. And then 2 times 1, which is a 2. So this is the answer. In number 2, so 3x cubed is already one term. So that's already one term means a factor form. And then denominator, you can pull out the 3 as x minus 2. And then x minus 2 is already the prime, which is a parenthesis around. X squared already one term is a factor form. So time to cancel. So cancel x squared with the x cubed as a 1 left. And then, 3 cancels out too as a 1. And then x minus 2 cancels. So on the top, numerator, everything cancel except x. And denominator, everything cancel except 1. So answer is x. All right, number 3. All right, in number 3, in numerator, the I'm talking about the 4a squared plus 4a. The GCF is a 4a. And then you got the a plus 1. And denominator, a squared minus 25 is factorable because it's difference of two squares. So you can factor a plus 5 times a minus 5. And then a squared minus 5a, which is a squared minus 5a, which is a GCF is a, and then a minus 5 left. And then 4a is already one term, so that's already factor form. Now the cancels out. So I can cancel 4 factor from numerator to denominator. A cancels out, and a plus 1 stay, a stay, and the a minus 5 cancel. So yeah, we cancel everything except numerator, you have a times a plus 1, and denominator is a plus 5. You can put the parentheses around the a plus 5 or just leave it as a plus 5, that's fine too. Okay, so this is what I got. All right, now in the number 4, so x squared plus 5x, you need to use x factor to get 6 here, 5 here, x and x. And then two number from the 6, which is a 2 and 3, which is 2 plus 3 is a 6. And then 2 plus 3 is a 5, 2 times 3 is a 6, it works. So you got x plus 2 times x plus 3. And then also the denominator. Now you have negative 6, negative 1, or x and x, and then 6 has 2 times 3, which you need a negative 1. So this is how you do. So you got x plus 2 times x minus 3. For the 2x squared minus 5x, you can factor as. Now this time is you need to multiply 2 times negative 3 has negative 6 and negative 5. And then you put the 2x. And so the negative 5 difference is 1 and 6. I put the minus 6 here. So when you multiply 1 and negative 6 equal to negative 6. When you added it, 1 plus negative 6 negative 5. So it works. So now you got, but this is a reducible. So 1 and 3. So now you need to write as 2x plus 1 times and x minus 3. And then x squared plus 6x plus 9, I hope that you remember this. This is a special product, which is the perfect square trinomial. So pull out the root from x squared, pull out the root from the 9, which is a 3, and then make a square. Or you can just say x factor 2. So x plus 3 and square, okay? Alrighty, now, time to cancel. So you cancel the x plus 2 from the numerator denominator. X plus 3 you can cancel, but you cancel only 1. And the x minus 3 has been canceled too. So you got the answer as 2x plus 1 and then x plus 3. And then you're done. In number 5, now same thing here too, right? So x factor, when you have a trinomial, use x factor. Otherwise, you don't need to. So x squared plus 8x plus 16. So that is also the perfect square trinomial. So we don't really need it, okay? So if you pull out the x squared plus 8x plus 16, and then pulled out the root, add it up, and then square. So this becomes x plus 4 squared. And then x squared plus 4x is LCD is x times x plus 4. And then this one we need the x factor for the x squared minus x minus 6. So negative 6 and negative 1 and x, 2 and 3. And this must be negative to get negative 1 as a sum. So you got x plus 2 times x minus 3. And then x squared minus 16 is difference of 2 squared. So you need to pull x plus 4 times x minus 4. And then time to cancel. So x plus 4, one of them cancel. This. And this whole thing cancel by that. And then what else? I think that's it, right? So okay. So whatever remainder factors are x plus 2 times x minus 3 over x times x minus 4. And then you're done. Alrighty, the number 6. Number 6, okay, so we gotta put this to the negative 14. I'm factoring this. And then I put 5 here, x here. So from the 14, yeah, 2 and 7. But I need a positive, so this must be negative, right? So you got that as x minus 2 times x plus 7 over. And then I'm factoring the denominator, which is 7 and negative 8, and then x and x. So from the 7, 1 and 8, right? But both are negative. Oh, 1 and 7. What am I talking about? Sorry. 7. But both must be negative, right? Okay, so you got that as x minus 1 times x minus 7. And then x minus already linear. And then x squared minus 49 difference of 2 squares. So x plus 7 times x minus 7. Then time to cancel. So x plus 7 cancel. X minus 1 cancel. Then everything cancel. So except you got x minus 2 over x minus 7 times x minus 7. And also you can write as x minus 2 over x minus 7 squared. Okay. Alright, so that's for the first page. And then let's take a look at the second page. In the second page, now we are dividing. So when you're dividing, only difference is step 1 actually. There's a one more step. Because as long as you need to change the multiplication, and then we just do as a problem, we just did it on the first page, okay? So the page is really easy. So first of all, I need you to change to the multiplication problem. So multiplication problem is how to do that. So first 3x plus 9 over x squared stays the same. And then the second one we need to flip, which is x cubed over 6x plus 18. Now, you do the exactly same as a multiplying two rational expressions. So, you need to factor. So, factor 3x plus 9. You can pull out 3 of x plus 3. X squared is a factor form. X cubed is a factor form. And then 6x plus 18, you got pulled out 6 as a GCF and plus 3. And then time to cancel. So cancel, 3 goes 3, 1, and 6, 2. X plus 3 cancel. X squared cancel. Then everything cancel except I still the answer. In number 2, okay, so you can make a fraction form first if you want, okay? So always put the one on the bottom, make a fractions. Any of the number, right? Any. So you got ax squared plus 5x minus 24 over 1. And then you got to flip the second rational expression always. So a plus 8 and a minus 3. And the only place you can need to factor is going to be this numerator. So x factor. So negative 24, 5, x, a, and a. And two number from the 24, which is 3 and 8. Has a difference of 5, so negative and positive, right? So you get that as a minus 3 times a plus 8 over 1 times a plus 8 and then a minus 3. But this already, so you can just put the parentheses around if you want. And then this has been canceled, right? So you got a plus 8, but there's a choice, so we can just break a square. Okay. All right, now number 3. Same idea, okay? So what we're going to do is, I'm going to change to the multiplication problem, which is x squared minus 3x minus 10, x squared minus 8x plus 15. And then you put x squared plus x minus 12, and 3x squared plus 2x minus 8. So factor it out. The x squared minus 3x minus 10, which is negative 10, negative 3, x and x. So from the 10, which is 2 and 5. So positive, negative, right? So you got x plus 2 times x minus 5. And then now I factor the x squared minus 8x plus 15. X factor, trinomial, 15 and negative 8 and x and x. So find the two numbers of 15 and sum of 8, 3, and 5. So it has a negative. So you got x minus 3 times x minus 5. And then factor the x squared plus x minus 12, which is x factor, negative 12 and 1, and x and x. 3 and 4, right? But I need a positive one, so negative, right? And then positive. So you got x minus 3 times x plus 4. And then the last one, now this time you need to multiply 3 to the negative 8, right? Because a is not 1 anymore. So negative 24 and 2 as a 3x and 3x. So 4 and 6, isn't it? And then minus and positive, right? So, but this time 3 and 4 not reducible, 3 and 6 reducible, so 2, right? So what you need to write it is, you got 3x minus 4 times x minus 2. Oh, x plus 2, right? It's a plus, sorry. Okay, time to cancel. So you cancel x minus 5, x minus 3, x plus 2. Oh, so everything cancels except you get x plus 4 over 3x minus 4. So that's all. All right, the last one, number 4. So number 4, you have, change the fraction form. So x squared plus 3x plus 2 over x squared plus 1 times. Now flip it. 1 over 5x squared plus 10x. So now factor, which is, I'm factoring the x squared plus 3x plus 2, which is x factor, 2, 3, x, and 1 and 2 only, right? The 2 had only 2 factors. So you get the x plus 1 times x plus 2. And then the denominator x squared plus 1 is not factorable. So if it's not factorable, just put the parenthesis around to make a one term. And then 1 over. And then denominator 5x squared plus 10x, you just need to pull out GCF, which is a 5x. So x plus 2. And then the time to cancel, okay? So cancels out as x plus 2 only. Yeah, that's all. So what you needed is, I see the x plus 1 times 1, which is x plus 1. I still see the 5x times x squared plus 1. Alright, and then there's no more cancellation. Alrighty, so that's for the how to divide the rational expression. Okay, thank you for listening.